This is section 3.7, solving inequalities. So let me share with you the screen. Okay, so we have to do 3 through 35. Skip 21. So we're on page 352, it looks like. More setup over here. So there's 3 and 5. So it looks like we've got a polynomial in general, less than, equal to, or less than, greater than, or greater than, equal to. And then we have some fractions where we're doing the same thing. All right, so number 5, x plus 5 squared, x plus 3, x minus 1 greater than 0. First, the zeros of the polynomial are your boundary points. So your boundary numbers are -5, -3, and 1. Put them on the number line. Okay. Each of these do not satisfy the original inequality. If I plug in -5 here, here, and here, or -3 here, here, and here, or 1 here and here, in each case you get 0. 0 greater than 0 is false, so they're open. If you had a line underneath it greater than or equal to 0, they'd all be closed. Pick a number in each region. Region 1, 2, 3, 4. So region 1, I pick -6, region 2, -4, region 3, 0, and region 4, 2. You plug into the expression and see if you get a positive or negative quantity. I noticed that if I have anything squared besides -5, you're not plugging in -5 anyway, it's positive. So plus, 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 that's off of that. Okay, -6 plus 3 is negative. -6 minus 1 is negative. Positive times a negative is positive. Is a positive greater than 0? Yes, that's true. Shade in region 1. Region 2, -4. That's already positive. -4 plus 3, negative. -4 minus 1, negative. So positive times negative, positive. That's true. Shade in region 2. Region 3 is 0. That's already positive. 0 plus 3 is positive. 0 minus 1 is negative. Multiply them all together, you get a negative. Negative greater than 0, that's false. Do not shade in region 3. Finally, region 4, 2. Positive, positive, positive. They're all positive. Positive greater than 0, true. So the only false region is region 3. So I'm going to have negative infinity, -5, union -5, -3, union 1 to infinity. 7. First, you have to have 0 on the right-hand side. So subtract these two over. Factor by grouping. X squared, x plus 4, minus 4 times x plus 4. Factor out the x plus 4. And x squared minus 4 becomes x plus 2, x minus 2. All right, so it's completely factored. So my boundary numbers, boundary points are -4, -2, and 2. This time, because I have greater than or equal to 0, all 3 boundary numbers are closed circles. If I plug in -4 here, here, and here, this will say 0. 0 times anything is 0. 0 is greater than or equal to 0 is true. Similarly for -2 and 2. So I pick a number in each region. Region 1, -5. Region 2, I pick -3. Region 3, 0. Region 4, 3. Plug in here. -5, negative, negative, negative. 3 negatives make a negative. Negative greater than or equal to 0, that's false. Don't shade in region 1. Region 2, -3. Positive, negative, negative. That makes the whole thing positive. Positive greater than or equal to 0, that's true. Shade in region 2. Region 3. 0, positive, positive, negative. That makes the whole thing negative. Negative greater than or equal to 0, that's false. Do not shade in region 3. Finally, region 4, 3, positive, positive, positive. Multiply them all together, positive. Positive greater than or equal to 0, true. Shade in region 4. So bracket -4, -2, bracket, union, bracket 2 to infinity. Okay, 11, x to the 4th minus 7x squared minus 18 is less than 0. This is a quadratic in x squared. I can write it as x squared minus 9, x squared plus 2. You can double check my multiplying back out. This thing's always positive. We're doing real numbers now, no imaginaries. This is x plus 3, x minus 3. So my boundary numbers are plus or minus 3. So region 1, -4. Region 2, 0. Region 3, 4. They're both open circles. We have a strict less than 0. Okay, so if I plug in either -3 or +3, it'll say 0 is less than 0, which is false. If you had the line underneath here, they'd be closed. Okay, this expression is always positive, x squared plus 2. So that's reflected over here. So I just have to worry about these two. -3, so -4. -4 plus 3, negative. -4 minus 3, negative. Negative times a positive is positive. Less than 0, false. Don't shade in region 1. Region 2, 0. 0 plus 3 is positive. 0 minus 3 is negative. That's always positive. Multiply them together, you get a negative. Is a negative less than 0? That's true. Shading region 2. Region 3, 4. Positive, positive, positive. Multiply them all together, you get a positive. Is a positive less than 0? No, that's false. So only region 2. So my solution set is negative 3, 3. All right, for quotients, something divided by something, you set the numerator and the denominator equal to 0 as my boundary points. Okay, so what makes the numerator 0? 1. What makes the denominator 0? 10. So 1 and 10. Plugging in 1 and 10 will give me a false statement. So plug a 1 here, 0 less than 0, false. Well, you're not even allowed to plug in 10, right? 10 minus 10, you're divided by 0. That's a no-no. Okay, so region 1, 2, 3. Put 0, 5, and 11. 0 minus 1, negative. 0 minus 10, negative. Negative divided by negative, positive. Positive less than 0, no, that's false. 5 minus 1, positive. 5 minus 10, negative. Divide them, you get a negative. Is a negative less than 0? That's true. Shade in region 2. And region 3, 11. 11 minus 1, positive. 11 minus 10, positive. Positive divided by positive, positive. Positive less than 0? No, that's false. Do not shade in region 3. So my solution set is parenthesis 1, 10 parenthesis. 23, you got to do some factoring first. So this is x plus 3, x minus 1, 3x plus 2, x minus 3. So my 4 boundary numbers are negative 3, 1, negative 2/3, and 3. Here they are. We have strictly greater than, so they're all open. So I have 5 regions, 1, 2, 3, 4, and 5. Region 1, negative 4. Region 2, negative 1. Region 3, 0. Region 4, 2. Region 5, 4. Okay, and I plug into this expression, I rewrote it here. Okay, negative 4, negative, 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 negative. 4 negatives, positive. Positive, and we're trying to find out if it's greater than 0. As soon as we can get this into focus, greater than 0. So greater than 0, that's true. Shade in region 1. Region 2, negative 1, positive, negative, negative, negative. 3 negatives makes a negative. Negative, greater than 0, false. 0, 0 plus 3, positive. 0 minus 1, negative. 0 plus 2, positive. 0 minus 3, negative. So I have 2 positive, 2 negative. That makes the whole thing positive. True. Region 4, 2. 2 plus 3, positive. 2 minus 1, positive. 3 times 2 plus 2, positive. 2 minus 3, negative. 3 positives and negatives makes a negative. Negative greater than 0. Whoops. It's false. Do not shade in region 4. And finally, region 5, 4. Everything is positive, looks like. 4, positive, 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 greater than 0. True. So negative infinity, negative 3, union negative 2/3, 1, union 3 to infinity. 27, I've got a 1 here. I'm not supposed to have a 1, I'm supposed to have a 0. So subtract over the 1. Multiply by 2x plus 5, top and bottom, we get a common denominator. So I have x minus 2x minus 3 minus 5. That's negative x minus 8. I could do that, but I don't like all the negatives. Multiply both sides by negative 1. That switches the inequality. So x plus 8 over 2x plus 5 less than or equal to 0. So my boundary numbers are negative 8 and negative 5 halves. This time, negative 8 does give me a true statement. Negative 8 plus 8 is 0. 0 divided by this is 0. 0 is greater than or equal to 0. So closed circle. However, negative 5 halves is still going to be left open. Negative 5 halves times 2 is negative 5. Negative 5 plus 5 is 0. You're never allowed to divide by 0. So here's our first example of close on one side, open on the other. Okay, so negative 8 and negative 5 halves. So negative 9, negative 3, 0. Okay, negative 9 plus 8, negative. 2 times negative 9 plus 5, negative. Negative divided by negative, positive. Positive less than or equal to 0. That's false. Do not shade in region 1. Region 2, negative 3. Negative 3 plus 8, positive. 2 times negative 3 is negative 6. Plus 5 is negative 1. That's a negative. Positive divided by negative is negative. Negative less than or equal to 0. That's true. Shade in region 2. Region 3, 0. 0 plus 8, positive. 2 times 0 plus 5, positive. Positive divided by positive, positive. Positive less than or equal to 0. No, that's false. So solution is bracket -8, comma, -5/2, parenthesis. Okay. And then 31. My boundary numbers are 1, -1, and -2. So -2, -1, 1. Region 1, -3. Region 2, -1.5. Region 3, 0. Region 4, 2. And this numerator, as long as I'm not plugging in 1, and I'm not, it's a boundary number, it'd always be positive. So plus, 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 plus. So the sign is determined by the denominator. Okay, -3, negative, negative. So two negatives make a positive. Positive greater than 0, true. -1.5. Well, that's already positive. -1.5, negative, positive. So I have one negative, makes the whole thing negative. And that makes it a false statement. Negative greater than 0, false. 0 looks like everything is positive. That's already positive. 0 plus 1, 0 plus 2, positive. 3 positives, positive, greater than 0, true. Shading region 3. Region 4, 2. Positive, positive, positive. Everything's positive. Positive greater than 0, true. Shading region 4. So the only false region is region 2. So parenthesis, -infinity, -2, union -1 to 1, union 1 to infinity. Okay. And let's see, 25. Got to factor by grouping. Factor out the x squared, x plus 3. Factor out the -9, x plus 3. Factor out the x plus 3, x squared minus 9, which becomes x plus 3, x plus 3, x minus 3. So I can write this as x plus 3 squared, multiplicity 2. Boundary numbers are -3, 3, and -4. So I'm rewriting the expression here. -3, 3, and -4. So -5, -3.5, 0, and 4. Plug in -5. This is always positive. Plus, 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 plus. -5 minus 3, negative. -5 plus 4, negative. So two negatives makes it positive. Positive less than or equal to 0. No, that's false. Region 2, -3.5. That's already positive. Negative, positive. So one negative makes the whole thing negative. Is a negative less than or equal to 0? That's true. Shaded in. Oh, there's not much in there. Region 3, 0. Positive, negative, positive. Again, one negative. That makes the whole thing negative. Negative less than or equal to 0. That's true. 4 looks like everything's positive. 4 plus that's positive. 4 minus 3. 4 plus 4 positive. Multiply them together. Positive. Positive less than or equal to 0. Nope, false. So I just have this region and this region. Region 2 and 3. So -4, -3, union -3. 3 is my solution. All right. Okay, so that was section 3.7 on inequalities with irrational expressions.